No fear, no fear, no fear, no fear, no fear, no fear here and declare your independence with me, Ernest Hancock, here in Phoenix, Arizona, from the BEA beautiful studios of Freedoms with an S, FreedomsPhoenix.com. All right, we've been looking forward to this for a while. Ali Kazemian is from Contour Crafting, contourcrafting.com, CONTOURCRAFTING, contourcrafting.com. You go there and you'll see that they're doing a 3D printing of buildings, apartment buildings, factories, homes. This is, happening not later, okay? So we want to make sure that we get in that. I'll tell you a little bit about Ali. He's a research and development engineer at Contour Crafting Corporation, also a PhD student at the University of Southern California, USC. Ali received his bachelor's in 2010 and master's in 2012 in civil engineering with honors from Tehran Polytechnic in Iran. He earned a second master's degree in computer science from USC in 2017. His research focuses on automated construction through concrete 3D printing and real-time quality monitoring of the process. His past research works have resulted in publication of a book, 11 journal papers, and many conference papers. He is a voting member of ACI 552TG, whatever that means, Additive Manufacturing, a member of the RELEM Technical Committee on Digital Fabrication with Cement-Based Materials. Okay, so the boy's got computing skills, CAD skills, engineering skills, and he decided that I'm going to 3D print houses because I have no idea. Let's go ahead and ask him why. Ali, help me with that. Go ahead and give us a little bit more about yourself so people know who we're talking to. Would you please?
Hi, sure. As you said, currently I am a research and development engineer at Contour Crafting Corporation here in Los Angeles, and also I'm a PhD candidate at University of Southern California. My PhD advisor is Dr. Bero Koshnevis, who is also the founder and CEO of Contour Crafting Corporation, and actually he's the one who started the whole movement of large-scale 3D printing and construction-scale 3D printing about 20 years ago. And
Wait, time out. They've been doing 3D construction printing kind of stuff 20 years ago?
He just proposed the idea about 20 years ago, and our research group has been working on different aspects of, construction scale 3D printing over these 20 years. And, I told you that there are many pieces of the puzzle, like material delivery, the robotic system itself, and the project management aspects. So the group has been working on different aspects over the years, and more than 100 patents have been filed over these 20 years. So there's been a lot of work on it, but now is the time that we think it's the right time to commercialize it and get more serious about it.
Okay. Have the machines to do? I'm looking at a video here with the design of the 3D printer house thing. The actual printers been made to where a developer can buy them?
Right. So we have the second generation of the printers already in the company, but they have not been commercialized yet. So we are going to do several demonstration projects first to show everyone that it's possible and it can be an efficient process and it can be cheaper than conventional construction. And after that, they will be available for sale.
Well, how long are we looking at? Because I'm I got, you got a customer here, man. What's up?
Right. So demonstration projects, definitely we will have one in 2018, even more. To show the whole process of building or printing a building. And about commercialization, I think that would be next year and after that.
Okay, so there have been some demonstrations. I mean, one thing I can do right now, I'm going to do for the audience, I'm going to let a video play that we have done from your website, and it shows the mechanism by which it does this. So I'm going, dang, this is already happening. You've done some demonstrations of building the walls and such, haven't you?
I mean, yeah, for wall, that's right. We have built like structural elements like walls in our lab using our previous versions of the machine. But the whole building, no, we have not done it before, and we're gonna do it in 2018.
Okay, I'm. Where is this going to be done? You guys are, located what part of the world?
We are in California, so the company is in El Segundo, and we are going to do first of all one demonstration project in our laboratory. So we have a huge space in El Segundo. We're gonna do it there, and after that, we will definitely do it on the field.
Okay, now here we have the. I'll turn the sound off. But here we have the actual design that you're doing. I'm going to let that play so people can see this. Because damn, I'm. This is a great. We've seen some demonstrations of various different, walls and curves and such. I mean, what are you doing the research at? Where are you testing it? You got a warehouse you're in, and then you take a bulldozer and scrape off that wall and do another one. I mean, how are you doing this?
That's right. So there are many different challenges that we are facing, in terms of the robot and the robotic system. There are lots of things that we have to take care of, and our concern has been that the robot has to be lightweight. So few people can send it to the construction site, and it can be assembled and set up in like less than 2 hours. And after that, the construction can easily start. So we have been thinking about the whole process and try to make the robot lightweight and make the whole process, reliable and robust, because we are talking about like 24 hours of continuous construction. So every piece of the equipment has to be reliable, has to be robust, and we cannot afford any kind of failure during that process. So that's why it's taking some time, and we are trying our best to make the whole process reliable. And also, of course, in terms of materials, we also have a lot of challenges in terms of the properties of the fresh material, in terms of viscosity and rheological properties and timing of layers and things like that.
Well, to make sure that people understand the material as it comes out of the concrete extruder. Is it concrete? Can it be a polymer? Can it be something else? What are the range of materials that you've been using?
Yeah, sure. So in terms of possibilities, yeah, definitely there. You can use all sorts of materials as long as the rheological properties and the viscosity is right. So over years, we have been using like gypsum-based materials, cementitious materials like concrete, and things like geopolymers, which are also the possibility, and actually some people are doing that. But after testing and playing with all these materials, we came into the conclusion that like concrete is really the best options. It's familiar in the construction industry, everyone knows it. There is a variety of chemical admixture to adjust the properties of concrete, and you can find Portland cement almost everywhere. So we think that this concrete is the best option to use with contour crafting and with large scale 3D printing. And we have been working and doing research on it to optimize the properties. And for example, using fibers, we have been able to use all kinds of fibers, like steel fibers, 1-inch steel fibers, and composite fibers to address the reinforcement issue that you mentioned a few minutes ago.
Well, is there so you're talking about placing rebar, or are you talking about, small fibers in it, like, basalt or fiberglass or, carbon nanotubes or, whatever, and how long do they have to be, before they have an impact, and how short do they got to be so that they can run through the machine? So it's are you talking about actually constructing on steel rebar or having to place it, or is it inside the material?
Right. So we have some ideas for placing reinforcement, but not continuous reinforcement, like segmented pieces of rebar in parallel to the concrete printing part. But that's for maybe longer term, what we are doing right now is using pieces of fiber, as you mentioned. And for example, 1-inch steel fibers, we blend it with concrete right before extrusion, and we print fiber reinforced concrete. So those, composite or steel fibers, they they do the same function that rebars do for us, and that's
Okay,
reinforcement of the structure.
I'm looking for this is damn. This is going to be the future. I'm just shocked that it's not already being done. Is it already being done, or is it just test homes? Is there I can order the equipment? How you're starting to make it? I mean, is it 2020? I'm ordering the actual printer and I can start my own business.
Yeah, definitely. I think by 2020 you would be able to order and have your concrete printers. And in terms of what has been done, there have been definitely some demonstrations in different countries. There's a lot of hype and claims in terms of printing buildings in one day, but actually, there are some doubts, and we know that there have been some difficulty even on the demonstration projects. So no one actually has been able to really print a building in one day. It always takes several months for them to build one small building, and that's still a challenge to overcome.
So, well, I've seen them. They built the house in a day. I mean, you're saying they didn't really, or it's going to be more complicated than that. I mean, what are you saying?
I'm saying it. I mean, the active printing process, it might be in 1-2 days, but the whole process that it took them to build it's like several months.
So to get ready. I mean, from the time that they actually started, pouring stuff, it may have took a day, but there was a whole bunch of setup time and getting ready, I imagine.
And right, and some failure happened in the process, and they had to stop for several weeks, fix some equipment, and then start again. Okay. That's what happened, and no one has really done it in 1 or 2 days.
What are the limits on 3D printing for homes, Ali? I mean, do you think in the future, as you're developing this process, that there's something you can't do?
Right. So there are actually lots of things that currently we are not able to do, but definitely we are thinking about doing them in future. One of them, as you mentioned, are the other things other than building the walls, like plumbing, electrical network installation, and after the walls are ready and printed, there is still work to do, like finishing and tiling and those kind of things. And again, we have ideas to automate those processes as well, but currently we are not able to do that. And also, at least in short term, we are talking about single-story buildings. But we know that there is a huge need for high-rise buildings and, for like multi-unit buildings, like villages and those kind of things. So yeah, there is a lot.
Well, I've seen, we've had robots on the site. We have our website, freedomsphoenix.com, and then pirateswithoutborders.com. This is where we highlight a lot of the new tech that is available for being having a decentralized life. You do it yourself. You're off. You can sustain yourself and do a lot of things yourself. And with 3D printing, you can design it yourself. And I'm wondering, there'll be software that'll help with the engineering and make sure your spans aren't too much, or you can do different things and make sure you got to use this material and all. I mean, it's going to happen. This kind of is already done with 3D printers now, to be able to have different support structures here and there that either automatically prints or you place so that it can do different arches and blah, 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 blah. I see it coming. And it's going to be, all of a sudden, 10 years from now, you're going, damn, why did it take so long? And here it is. But we have robots that are placing brick. They're building brick walls. They got hell, they're going to have humanoids that are going around, taking care of us and doing and building and laying tile. I mean, this is coming. So I'm wondering where the resistance is coming from. Is there resistance? But you got some trade unions that, come in and sabotage, like the Sabo. They're throwing their wooden shoes into the machines at the mill. You got some opposition?
Right. So there are a few things that I can mention. First of all, construction industry is actually a quite conservative industry. Maybe the reason is that the profit margins are quite low, so there are not so many people in construction industry who are ready for a change, who like things to change. And also things have been done the same way in construction industry for long years, for a long time. So everything is somehow streamlined, different trades. They have found ways to work with each other and make it efficient, although the whole process is not efficient at all. But I'm saying it's been done the same way for a long time, so it's not easy to change it. And the other thing which I hear is that a lot of people, a lot of construction workers, they might lose their job as a result of automation of the construction process, which I really don't think is true, because a lot of new and more creative jobs will be created by technologies like contour crafting, and some people which were not involved in construction before, like women and old people, they can now become involved in this new process of construction. And
a lot of people, they don't realize that there is, God, half the planet's not even online yet. You have half the planet, or more, that needs this kind of housing. You're going to have a enormous demand for the machines that you're doing, and there needs to be companies and individuals here in the high-tech United States of America manufacturing these kinds of machines for the planet. It's going to generate so many different jobs here for the people that have low-cost housing and low-cost everything else, over there. There's so much available for us to really expand upon and take advantage of. And I'm just wondering, is it just unions? Is it government? Is it? I mean, who's the naysayers? Who's the stick in the mud? Who needs to be made fun of?
I think no, it's not definitely government or anything. It's just the spirit in the construction industry, being conservative that I mentioned.
Well, define that. You say conservative. What the hell does that mean? They're just like, we don't want to make as much money, or we want.
No, it's just the trust that they have in the old approaches and the conventional methods of construction that have been in place for several decades. That's difficult to change, That's
it's gonna change, though. I mean, you're feeling that it doesn't matter. It's going to happen whether they like it or not, right?
Exactly, yeah. And you mentioned a good point about the need that we have. I mean, in Los Angeles, we have a large number of homeless people, and there is a need for emergency housing. Things like hurricane or tsunami, after they happen, a lot of people, they lose their house in a matter of seconds, and they need, I mean, there's a need for them to have buildings built for them as fast as possible.
Well, this is the one criticism might be that, hey, man, I mean, literally, it's going to be cookie cutter homes. They're going to be just the same assembly, a robot coming out. But, just with a flip of a switch or a click of a mouse, you can round the corners, change the design, make it look, I don't see with this kind of building, I don't see why you would be restricted to anything that you'd want to make as long as it was structurally sound. I mean, you can do every home in a development could be different.
That's exactly right. With this kind of robotic system, you can have all kind of curved features, as you mentioned, and you don't have to have those boxy designs that you usually see for buildings, which are actually not good in terms of strength. So I mean, there's a lot of freedom in architectural design now.
You make it better for America and the rest of the planet, and you're creating an entire industry that be a benefit to everybody. And there's going to be, mistakes, problems, whatever. I don't care. What's happening is that there's so much innovation that it's going to be disruptive of a lot of different industries. But to whom and why? It's going to be government regulation of you're allowed. And they're going to say, you come in and you can demonstrate and show that this is stronger, better, faster, cheaper, benefit humanity. and they'll go, no, because you didn't, provide something for this company that got me elected of a special interest to provide me. This is where we come in, Ollie. This is where we can help. This is where we, using our audience and social media and for the right and the good of the benefit, if you get to where they're giving you some kind of hassle, we're the guys that you call. And you say, look, man, seriously. So we highlight it and bring attention. But the elected politicians, they don't care. They're there for that reason. That's why they got there, was to block this kind of stuff. But you just wait till the next election. But you got to get started early. You got to have a good information and PR campaign. And so, please include us. But has there been discussions and efforts to demonstrate this to government officials that you are doing good by America and the planet? Tell us about that.
Right. So, there have been some collaboration with government agencies. Like, we have several ongoing projects with NASA. So, and also I remember we were approached by FEMA, so that they were interested to know more about contour crafting. And
who's
FEMA?
Who's FEMA?
It's FEMA.
Oh, FEMA.
Right.
Okay.
Yeah. So
Emergency
they were interested.
management.
Right. That's right. So they were interested in using contour crafting for emergency housing. So after natural disasters happen, as I said, a lot of people they lose their home, and the government would be able to build a lot of houses in a short time, and that's a very interesting application for contour crafting, which we're also thinking about. And also the low income housing and the homeless people, that's an issue that we are dealing with, and I think contour crafting would be a good solution for that. So I think, if we can solve the technical issues that we are dealing with and show everyone that it can be done and it's a reliable process and the performance of the structure is equal or better than conventional construction, I think considering the need, it would be able to go big.
Well, what do you think? The construction equal to or better than. God, it seems like just a touch of a click of a mouse, a button of you add, and you can make it better. Does it? What are you thinking? Are you looking at it's going to be difficult to be better than, or it's easy, or what?
Oh no, definitely. I was just talking about the structural performance of the buildings, but there are some benefits that no one can deny. In terms of the construction speed, a normal 2,500 square feet building usually takes about 6 months in the United States to be built. But now we are talking about like 1 or 2 days using contour crafting. That's a huge advantage in terms of time, and time is equal to money. And also safety is another one. It's another advantage that I think no one can deny it. When you have people on the construction site, there's always the risk of different accidents happen, and actually thousands of construction workers they are injured or killed on construction sites each year in the United States. But when you have a robot doing the job, then of course you have almost zero chance of anyone getting hurt. And we already talked about the architectural design. As you said, we can definitely have better designs in terms of the architecture of the building, and of course, there's no reason for two buildings to be the same anymore. We can have every building customized at no additional cost. And also think about the material waste. In conventional construction, sometimes up to 20% of the material is wasted.
That's another thing. When you're doing this, it's like everything that you print goes into, the construction. It's not like there's a lot of waste,
Exactly.
So when you do that, but you're using concrete is like everything. So I'm going, all right, what's the expense of the concrete? If I had the material cost of a 2,000 square foot 4-bedroom house and it costs X, how much less or more is the actual materials of the concrete? Now, of course, labor is going to be way down, but the cost of the material, how does that compare?
Actually, since last year that the company has started, all our efforts were made so that the material is not more expensive, or at least much more expensive than the conventional concrete. so that it's not an obstacle into use of contour crafting. So the material is not significantly different, maybe 10 to 15% more expensive than conventional concrete, I mean. But if you consider the fact that you don't have labor expense and the time of construction is much faster now, I think that 10 to 15% would be easily justified.
When do you think we'll start seeing this really ramp up? When you have a developer will come to Arizona and they'll go out in the desert you get to customize and 3D print, and here's some base models of a whole bunch, and it costs this, and we can figure it out we push a button. The computer said, yep, it has this much square yardage of material, it does this, it has that, and if you want this, it costs another $283.16 to add a whatever for the kitchen or something. This is because it's going to be way more creative in what you can do. It would be really your architect is your 3D print design guy. And,
That's right.
The material that you're doing, is it going to, I see people 3D print, I'm watching videos here, 3D printing different pieces of homes or playhouses or castles or whatever. And it looks like it's not so heavy they can't carry big pieces. Is this lighter than concrete? Are you having, air introduced into it? Is it, or is it, hard concrete because you got foundations? I mean, how customizable is the actual density of the material?
Right. So, we have tried different kinds of concrete, lightweight concrete, as you said, and different densities of concrete. That's all the possibilities. But in terms of what you said, as like printing just elements of concrete, elements of the building, and sending in and carrying it to the construction site, that actually would not be much more cheaper and efficient than precast industry that we already have, right? So contour crafting is all about doing the 3D printing on the construction site and in one shot. And I think that's where the most advantage of this automated construction happens.
Do you think there's going to be new materials that come out? It's going to be aircrete with carbon nanotube expanded foam, whatever the heck. I mean, they're going to come up with some weird, hell, they do 3D printing like they do with powders and lasers and metals. And I mean, is the sky the limit, or you guys think you got to go through this stage of concrete first?
Definitely research and development. There's a lot of possibilities like geopolymers or the materials that you mentioned. But in terms of, having a commercialized system and seeing people and developers really using it, I really think that the concrete is the best option. And you will see, I think in the next 1 or 2 years, you will see a lot of demonstrations happening using concrete. And I think in the next 5 years, you will see developers having these 3D printers and start printing buildings.
Are you working on software, or is there software out there that can be integrated into what you're doing to where people can design their own house and they have engineering software that can tell, you can't go that far a span without the yada, yada, yada? Is this going to be possible? People design their own houses and they can build it?
Yeah, that's definitely possible. And in terms of software, there's actually not any software that we can directly use for our system, but everything is customized. So we are developing our own software, considering the properties of our robot. And as you said, one nice feature of the software would be to determine if a 3D model is constructible, if our robot is able to print that design or not. So as you said, designers and people can easily design their own houses, and the software will double check it, considering the regulations and the capabilities of the robot, and after the design is approved by the software, then that's it. Just you connect to the printer, and the printer starts printing the structure.
Well, this is going to be in cooperation with what kind of company? They want to construct what you're saying, you're a construction company. They're looking forward to using it themselves, or are they looking forward to creating the machine to sell the machine, or do they want to keep that to themselves? What's their motivation?
Right. So our own company, the focus of our company would be to build the machines and sell them. And in the next few years, yeah, we will be working with the developers and construction companies. We will be like leasing our machines to them, so they will use contour crafting machines on the construction site to build a lot of houses, hopefully in a short time.
Okay, I'm rooting for you. Keep we may be in touch again, or you can certainly keep us informed, because I tell you, this is of great interest to us, because we had listeners that specifically requested that we get hold of you and someone like you to be able to tell us where we're at now. How long before you think we should be pinging you again? We have something new to talk about.
Sure. I think by the end of 2018, we will have quite interesting and exciting, news for you.
All right. Well, expect us to, contact you if you need to get a little extra buzz, or have another show, or add to something, or, promote, let me know, and we're all over it.
Sure. Thank you.
All right. Well, thank you very much for coming on, Ali. I really appreciate this. This is very inspiring. Good luck to you guys.
Thank you for having me.
You bet. Bye-bye.
Bye-bye.